In this video, we're going to talk about identifying functions using finite differences. Now, you may notice that the handout is already filled out, and that is because I already recorded this lesson, but unfortunately there was an issue and I'm doing it all over again. So it's already filled out and I'm just going to walk you through it. So we're going to start with polynomial functions. And it says, for each of the functions shown, state the degree of the function and calculate the finite differences. Determine how many times you had to calculate the differences until you got values that were all the same. So just some words here. Degree, we learned way back at the start of the course, is the highest exponent in our function. So if I'm looking at a of x, which is 5x squared minus 3x plus 1, the degree of that function is 2 because the highest exponent in that equation is a 2. Finite differences, we first learned how to do first differences in grade 9 when we were doing lines. And then in grade 10, you would have learned about second differences. And now finite differences just mean we're going to do it 2, 3, 4, 5 times so that we're not just numbering all of them. So when we're doing our differences, what we do is we start on our x side and we want to figure out what did I add or subtract to get from 0 to 2. So you could calculate 2 take away 0 to figure that out if you needed to use a calculator. But I discovered that from 0 to 2 I added 2, from 2 to 4 I added 2, from 4 to 6 we added 2, from 6 to 8 we added 2, from 8 to 10 we added 2, and from 2 to 12 we added 2. All of those numbers are the same. On the other side, when I did the differences, I would have done the same thing. So I would have done 15 take away 1 to get 14, 69 take away 15 to get 54, 163 take away 69 to get 94, 297 take away 163 to get 134, 471 take away 297 to get 174, and 685 take away 471 to get 214. So these are what we call our first differences because we have done them one time. On the x side, they're all equal, so I don't need to do those ones again. But on the y side, they are not equal yet, and part of what it asked us to do was determine how many times we would need to do the differences until we get values that are all the same. So what I did was I calculated the differences of my differences. Those are called the second differences. So I did 54 minus 14 to get 40, 94 take away 54 to get 40, 134 take away 94 to get 40, 174 take away 134 to get 40, and then 214 take away 174 to also get 40. So I now notice all of those differences are the same, and I had to do it twice. So I wrote that the number of differences that we needed to do until they were equal was 2. Okay. For the other two, I would strongly recommend you try them on your own. But if you would like, I'm just going to very briefly walk you through, but I would recommend pausing the video, trying them yourself, and then coming back. So with b of x, the degree here is a 1 because the highest exponent is that secret 1 on the x. I did the differences on my x side. They were all the same, plus 5. I did the differences on the y side. They were all the same at minus 10, so I only had to do the differences once. The last one is x to the power of 4, so the degree on this one is 4. I did all of the differences on the x side. They all worked out to be 1. On the y side, I did the differences the first time. They were not the same. So I did the differences of those numbers. They are still not the same. I did the differences of those numbers. They weren't the same. But when I did it for the fourth time, I did notice that they were all 24. So the first set here are my first differences, then my second differences, then our third differences. So it was the fourth differences that worked out to be equal. What I want to take away from this is that with a polynomial function, the degree of the function and the number of times that you would have to calculate the differences are going to be equal. That's really helpful if you have data and you want to try to figure out, is it x to the power of 3 or x to the power of 4 or x to the power of 10? You can use the differences to help you figure out what the degree is. So speaking of that, there is an example in question number 2. So question number 2 says, use finite differences to determine the degree of the following polynomial function. So I started by doing the differences on the x side. So I should mention on the x side, the numbers should always go up by the same amount, because if there isn't a pattern with what's happening with our x's, we will not find a pattern with what's happening with the y's. So on the y side, I did the differences. They were not the same. I did it again. They were not the same. I did it a third time and they were the same. So because I had to do them 3 times, my degree is 3. All right, our last one here just says, are there enough points in the following table to calculate the degree of this function, and then explain. So I started by calculating the differences for x and then doing the differences on our y values. I found that they were not all the same. 2 of them were the same, but the third one was different. And then I did the differences of those. They weren't the same. And then I did the difference of those and I just got 60. So the question really is having just this one single number enough for me to think that this has a degree of 3? And the answer is no. So I need to have differences that are the same. So if I'm just down to 1, it's not the same as anything else. I don't have anything to compare it with. So really, once you get down to 2, that's it. You can't really calculate if you don't have enough data. So what has happened here is that I really need to have more points to be able to figure out what the degree is. So I said, no, we don't have enough points in the table. We ran out of numbers before the differences were equal. Okay, so I'm sorry I didn't get to work through that with you, but hopefully it gave you an idea of how to do it and you can fill it out on your own. All right, I will see you in the next video to take a look at some exponential and logarithmic functions.